So for this project, I did Newton's law of cooling. Sir Isaac Newton created this law to state that the rate of temperature is proportional to the difference in temperature between a body and its surroundings. It is also equivalent to a statement that the heat transfer coefficient is constant. In heat transfer, Newton's law of cooling holds only for small temperature differences. This is one of Newton's most widely used laws in calculus. So for this project, I'm using the formula for Newton's law of cooling to calculate the rate of temperature change or temperature drop between a bowl of Campbell's chicken soup and the surrounding space. I am also calculating the temperature of the soup at a certain number of minutes. The temperature of the soup should be decreasing quickly since it is cooling and there is a negative instantaneous change. The formula for this law is T prime of T equals T sub S plus T sub 0 minus T sub S times e to the third T. So I found that the initial temperature of the soup is 140 degrees and it cools to 120 degrees in 5 minutes. The soup is left in a 70-degree room. So T sub 0 equals 140, T of 5 is 120, T sub S is 70, and T equals 5. So in this project, I solved for K, which is also called the decay constant, and I plug K back in to the formula to find the temperature and the rate of temperature drop. So in this slide, I found K, and I got a constant of negative 0.06729. And here's what I did to find K. And in this slide, I made a table with the temperatures, which is T of T, and the rate of temperature drop, which is also known as T prime of T. So for 0 minutes, I got 140 degrees. For 5 minutes, I got 120 degrees. And for 10 minutes, I got 105 degrees. And for 15 minutes, I got 95 degrees. Researching this has informed me of the various applications of Newton's law of cooling in a real-life situation. Any food or drink that cools down can be applied to Newton's law of cooling. This formula can be used to measure the difference between the temperature of a room and how much it cools down over a certain period of time. And from this information, I found out that the temperature of the soup at various times in minutes. So it is 120 degrees in 5 minutes. It is 105 degrees in 10 minutes, and it is 95 degrees in 15 minutes. The rate of temperature decay is negative 3.35 in 5 minutes, negative 2.345 in 10 minutes, and 1.65 in 15 minutes. So here are my sources.